Hi, this is Mrs. Martin, and I'm going to do notes today on interval notation. And within the interval notation, we're going to be discussing the domain and range of graphs. Before we begin, in interval notation, if you use parentheses, that stands for does not include, or you can write does not equal. Brackets mean includes or equal to. I also want you to know that interval notation goes from least to greatest. So we're always going to write the domain and range from least to greatest, where negatives are first, and then we go higher to positives. Just the lowest number is first. All right, one problem I'm going to do is number 1. So not only do we have to state the domain and range, we're also going to answer if it's a function. So number 1 is a function. It would pass the vertical line test. If I drew vertical lines, they would only touch once. Now for the domain and range. Before we begin, I see a key point right here. And this is the ordered pair 1, -5. The graph doesn't go to the right of 1, and the graph doesn't go below -5. We're going to use that in this domain and in this range. With my highlighter, I'm going to talk about domain. The domain goes from 1 and out that way forever. So here is my domain. It's equal to 1, and then it goes lesser. So the domain is -infinity to 1. And no, that's from least to greatest. The range, using another highlighter, know that it doesn't go below -5 and then goes up to infinity. So for the range, I'm going to put -5 to infinity. There's the first problem. Next problem I'm going to do is number 5. Number 5, is it a function? It is not a function. A vertical line, if I drew one right here, would touch twice. So that dot up in the second quadrant makes this not a function. I'm going to put no. And you know what? Now that I explained that, I'm going to erase that vertical line, but that proves it as not a function. Okay, now for domain and range. Remember, domain is back and forth. It's right to left. Again, these points over here, and I'm going to name these points. The first point here is 1, 2, 3, 4, 5, 6, -6, 0. And then, of course, that's -6, 1, 2, 3, 4. All right, so my domain with my highlighter is going to go from there to infinity because that ray is going on forever. So my domain, remember, I go from least to greatest. And then I'm going to be equal to -6 and then go forever to infinity. As for my range, the lowest point on my graph is this point right here. And that ordered pair is actually -1, 2, 3, 4, -4, -2. So that's the ordered pair -4, -2. And range again is the y value. So I'm going to use this -2. And this range goes from -2 up. So if I use a blue highlighter here, my range is going to go up forever. So my range here is equal to -2 to infinity. So there's 2 examples of doing domain and range. We're going to go to the second page of these notes and do a couple more. So when I go to page 2, I see 10 and 11 and 12, and it says practice graphing, then state the domain and range. Okay, I want you to know that 10 through 15, every one of these graphs, x, the variable, is to the first power, first degree. So that means these are all linear. These are all lines. So these are linear equations. The first 2 are special cases, so I just want to remind you what they look like. Number 10. Number 10 is a vertical line, and every value on this vertical line is at -4. It has no slope, looks like that, and And I'll go ahead and write the domain and range. The domain is -4. The range goes forever up and down, so it's all real numbers. Number 11, this is a horizontal line and it's equal to 6. How I know it's horizontal is it doesn't have an X and a Y, so it's a special case. So 6, a little shaky, but there it is. The domain is all real numbers because that line goes forever. And then the range is only 6. So it's equal to 6. Every point on this graph has a Y value of 6. Number 12, all I want to do with number 12 is I just want to graph it because sometimes the basic graphs are the hardest. So Y equals X, this is one of the most basic lines. It cuts the first and third quadrant in half. I want you to know that the slope of this line is 1, and the B value, which is the Y-intercept, is the origin. So it goes through the origin, goes up 1 over 1, and again, I explained it earlier, this is a graph that cuts the first and third quadrants in half. This line, domain and range, both are all real numbers. Notice that infinities, and I want to make it a little bit neater. This is an infinity symbol, means forever. It means going forever. And I want you to know that you always will use a parenthesis with infinities. Never going to use the bracket because it doesn't include, you can't include that. All right, moving on down. I want to do one more. And I want you to know, again, these are all lines, but let's do one. I want to do 15 and then we'll be done. I want you to know that the slope is -5 over 2, or you can write it 5 over -2. Just know the negative either goes with the numerator or the denominator. The B value. The B value is the ordered pair 0, 8, so that means the Y-intercept is 8. And now we're going to graph the line. Remember, slope is rise over run. So I think I'm going to use this first slope, and I'm going to count 1, 2, 3, 4, 5 down, and then 2 to the right. And then I'm going to graph this line. 2 points determine a line, so I have enough. And again, I want you to know that all linear functions, the domain and range, I guess I better be careful. I better be careful when I say all. But slanted lines that have a y and an x variable in them, their domain and range is always all real numbers. These special lines up here, 10 and 11, you can clearly see that the domain and range is different. All right, this is notes on interval notation for domain and range. And what I want you to do for an assignment is to complete the rest of the worksheet. Thanks.